Hi, because
Michael, actually, today we didn't get an email like about this meeting, so I wasn't even sure we are going to have it or not.
well, I sent a text to David a while back, and he responded saying that he wants to maintain this series, but he didn't.
Okay.
He didn't
Got
say that he was going to cancel this or not. I'm
Right.
trying. I have to leave the house in 30 minutes, and I was trying to connect to this on my Apple, but I just can't seem to make to get connection on the Apple because I don't have the details of. I have the link in this invite, but I don't see the breakdown of the password for the call as and the meeting ID.
Yeah, actually, it's like a direct thing. Somehow, even I just copy paste this thing on the web browser, and that's it.
And are you able? Have you tried to get in there on
No,
on an
no,
Apple iPhone?
no.
Yeah, it's annoying, you know.
Yeah, it says.
I it keeps
Yeah,
telling me you have to re-download the Zoom, but can't get in there. And
yeah. No, you are right, actually, because it might it says like 8838 something about meeting and password is like horribly long.
yeah, it would be great if they can switch over to Teams because Teams is just so much easier than Zoom.
Correct.
And
Yeah.
apparently it's much higher security now than Zoom.
Oh, absolutely. Yeah. Teams is everywhere. People are using Teams.
Yeah, everybody's using Teams, and yeah, it's been recommended because of the increased security as well.
Right.
So while I have you here, before David comes, you know, the last thing that we talked about with David was that he didn't have the resources to go and build this demo design, right? So
Right.
I talked to Tony, and Tony has just gone off on holidays, and we said, you know, if the DARPA project is going to be building an advanced package,
Yeah.
why don't we use that design to simulate the all the files that we want to use to
Yeah.
build that
Yeah.
design.
Yeah.
So in the past, I don't know if you had been there in the beginning, but in the past, when David was trying to build this design, he had requested that we provide him libraries for HBM memory modules and the UCIe in the JEDEC JEP30 format, which we did.
Okay.
Now that we have in that's going to be published next week, we took a series of design kits, material design kit,
Yeah.
assembly
Yeah.
design kit, and etc.
Yeah. Yeah.
And that format has been past all the JEDEC ballot processes. So it's
Right.
in the process of getting published, which should come out next week. My suggestion is to take the rules that would go into the DARPA advanced package project to put it into that format. So
Yes.
the two things I need to get in order to create the files are what are the standards components that we need to mock up in JEP30 formats, because if you're going to have a HBM, then we have that done. If you're going to have a UCIe, we have that done. But if you're using other type of interfaces or other unique dies that are not standardized, we need to get the details of those so that we can create the part models for them, so that when
See,
we get to the point of making the design, you have all of the model libraries ready.
right. So So for us, we are not actually limited to HBM or anything. We are proper like 3D heterogeneous integration, which means two different chiplets, different completely. So now, we have quite a few test chips, but we cannot actually discuss the details because it's DARPA. So now we can actually pick any two that way, and we can actually start working. Like,
Yeah, okay.
let's take one.
I lost some of that now because you were I didn't hear everything. So maybe you could
Oh,
repeat
okay.
that.
So I'm saying like we do have plans to do like complete 3D heterogeneous and all with different chiplets, but I cannot actually disclose that because it's DARPA project, right? So we can take any two heterogeneous, not HBM or known, or whatever, like whatever you prefer, we can actually work on it because we are working to create a flow. Okay. So we can take whatever interfaces we agree upon and we can work on it. This will create our framework and will give you what you want with the format of JEP30 format. It doesn't have to be like we.
Well, if you can take anything, then
Yeah.
why not take the existing
I can.
HBM modules and UCIe
Yes.
modules?
Yes, I can. That's what I was saying, that we are not bounded by anything, but if this is what we want, like if this actually gives us a good idea of our proof of concept and framework, sure, no problems.
All right. So our goal was that
Uh-huh.
we would take these inputs. Let's say each of these are individual components that makes up the final assembly of the advanced package. The intent was that we would create individual part models for each input component, individual models for the design rules, and then through the design tool, we would create an advanced package. Now that advanced package will become a component of the next higher level assembly, which might be a printed circuit board assembly. And so you would need to be able to create another JEP30 model for the completed assembly. So in order to do that, we need to then understand what the floor plan of all the stage one components going into the advanced package, so that we could create a JEP30 model representation of that advanced package. And by having all of these pre-created JEP30 models, you would be able to say, right, well, you know, we need to go from this set of inputs to this set of output, and have the files like prepared for you so that you could use it as reference during the design flow.
Okay.
Now, what I have are the two inputs, but I don't have the floor plan to calculate what the output would be. And that's the piece that we're currently missing. I don't have samples of the rules that would go into the MDKs or the ADKs. I do have a sample of content to go into the MDK, but I don't have the sample of content to go into the ADK or the substrate design kit. Okay,
so let's actually see ADK, for example. Let's see what all parameters are there. Do you have it handy, or I need to find that out?
I have the structure.
Structure. Yeah, okay. Take one or two examples and see how we can put it. It's going to be similar. If I understand right, it's going to be similar to MDK. So
it's in the same structure. Okay.
Yeah.
So let me see what I have here now. Now we may not have enough time to do it because, as I said, I have got a hard stop.
Yeah, sure. And we can discuss it offline next week, or we can discuss it again. Let me think about it based on our today's discussion.
And if you could if you could send me in advance the rules, I'll have one of my guys help me put it into the right format, because it's a lot more.
And we might not have exact rules because we are still working and we are trying to actually come up with fabs and all that, right? We don't know the parameters yet, exact parameters, but nonetheless, we will use some decent dummy ones.
Right. I'm completely open on Monday and 90% open on Tuesday. So if you send me a Teams link, we'll just get started. How do I share my screen here? Share.
And what's your email address, Michael?
Michael.Durkin@siemens.com.
Okay. Let me actually send you a blank. Let me.
I'm just sending it. Put it in the chat.
Okay. Oh, it turns out I have you.
Yeah. Okay. Good. Yeah, I think we do. Yeah, of course. Okay. So, can you see my screen now?
Yes. Yes.
Okay. Let's get. Okay. All right. So, take a top level, right? So this is the part model, right?
Yep.
It was designed initially to handle ordinary components. The basic concept of it up here is the identity of the part or component that you want to deal with. It can represent one part or 1,000 parts. But the concept is it represents everything that's on a data sheet. And down here, then, is all the technical sections. So inside, you have assembly, process classification, which is everything to do with how do you assemble that die on or that component onto a higher level assembly. The electrical section is very detailed, goes into parameters, give you schematic levels. It maps, shows you a mapping to the physical. You have all the various simulation models. You have reference designs, and then you have a software interface description.
Yes.
The environmental is all the material declaration. The package goes into a physical end component package style, or you can break it down into a die array, and inside the die array you have things like active zones, scribe, reference rectangle, reference to die, physical to die, and this can scale to billions of bumps, right? So we've already made a file to do it. Then you have all the supply chain stuff, including product change notices and product discontinuance stuff. So we have standard that's based on that. We have a thermal section that deals with the specifically to do with what is being represented in the part model. So it's not going in, if that component is going into a higher level assembly, we're not dealing with the thermal model belongs to the higher level assembly. We're dealing with the thermal model that belongs to the components that you're representing in the part model file.
Right.
Then after that, we have, these are the two new sections that's going to be published next week, right? So we have, the simple one is a generated ECAD model. So when you use the component in the printed circuit board assembly, you have footprints, you have symbol rules, you have a mapping file, and you have, and then what we have here is what is the origin of who created this model, because from a trusted traceability point of view, we need to have digital traceability now of that content. So in this set here becomes the set of design rules. So we here, first of all, identify what technology you're going to refer to. And you have a whole selection of these different technologies, both for PCB assembly and for advanced package. Then you have the package assembly design kit, the substrate design kit, the material design kit. So the material design kit, we have sample set of data that explains this, and it basically goes into first of all different types of materials, and those materials are then you can have a formal classification of those materials, and then you can have the rules that goes to that material. So you have electrical, thermal, structural, optical, and other property rules. So
Mhm.
on electrical properties, you typically have dielectric constant dissipation factor, bulk conductivity, bulk resistivity. These are equivalent, but one is a reciprocal of the other, and field strength. And so we have, for all of these different types, the structure underneath these are specific to that type of property. So when you go down underneath that, we specify the definition of that property according to its standard definition. We don't want just somebody sticking in the definition of stress and call it STRES, for example, without putting in the second S. It has to have the proper symbols so that you can properly recognize it. Yeah. And then when you come to define the values of stress, right? You can define it in an XY value or a Z value, or you might just decide to have it only in one specific value, right? Right. Now,
you have tolerances over there too. Okay.
And you have a test method that, because the stress value that you measure might be different based on the test method. Correct. So you have then stress unit of measures, which is all specified in the specific stress. But notice up here that you can have different conditions, because these different types of conditions can affect the stress value. Yes. So that, and this is the only set of conditions that applies to this type of stress. So the schema is very locked in to prevent the person from making a mistake. Yeah. And if you want, you can then, instead of expressing it as a discrete value, you can express it as a relationship, a rule, in which case you might have one specific rule if you want to have one generic stress graph, or you can have different graphs, one for the X direction, XY direction, one for the Z direction. Yeah. And so and down here, then you can have a complete graph structure in which you can reproduce the graph from a visual perspective, with the right axis, vertical axis, horizontal axis, the legends that's used, the way and color that you want to define the graph. All of that structure is a standard structure that we apply to all of the graphs. So that concept applies to every property that's under the material, and it's all tailored specifically to each property. So what's applies to stress is not something that applies to failure strength, for example, or refractive index.
Correct. Yeah. So this is what you need to create. Yeah.
So I have sample content to fill into that, so I can go and do that. What I do not have is sample content to fill into the assembly structure, assembly design kit. Now, assembly design kit, that type of structure is again based off a set of design rules. You might have different classifications of your technology. So, for example, you might want to go advanced, standard, advanced, complex, micro. You might have some other names that you want to have in there. You can, when you define the rules, so this is the assembly set of rules. So we first of all say, well, what's the classification of the rules? So we have fiducial, pad stacks, test points, bonding, terminal to pad ratio.
Yeah, and like in bonding, just for example, let me say if I'm thinking correctly. So suppose bonding, hybrid bonding. So within that, there will be like hybrid bonding, thermal compression bonding. Is that how it's going to go? Okay.
Yeah, exactly. You define what type of this is just a classification of the rules. Yeah. Now down here you have to apply the rules. But as I apply the rules, I'm going to be basing it off some rule conditions. So rule condition is made up like this. For example, if I want to do let's say, for example, here a trace to trace spacing. Well, what is the feature selection? Feature selection is the trace, right? And so you define that here, right? So that's the trace. So that's in feature 1. Where is that placement? Is it on the upper side or on the lower side, right? what is the control point on that feature? So is it based on the edge, or is the center, and is it with the maximum material and condition, the nominal material condition, or the minimum material condition? And then you might have additional ones. What type of rule is it going to be? So if I have a trace to trace or a trace to via, the first selection is the trace, the second selection is the via, and then you have all these things that you have to decide on, right? You also have in the area, maybe I want to only take this measurement between one region, inside one region, or between one region and another region, between a specific terminal group or a pattern group or a terminal pattern. So you have many different places and areas in which you can apply that rule. So when you come to the rule condition, you have to select the area, select the feature, and select the placement of that feature, and select the control of that feature. Is it like at the minimum, nominal, or maximum? And you do that for one feature, you do that for the second feature. So this becomes the rule structure on how to exercise the rules. What we're missing out of this now is the list of actual rules. So for example, a trace to via or a trace to trace, should I call the name of that rule TRACE-TO-TRACE, or should I call it T2T? These are different. These are different ways to describe that, and we're missing that piece, and that's what needs to go into another document. And if we can standardize on that, it now means that any EDA software tool can transfer the rules from one to another, and they immediately understand what the structure of the rule is and what the meaning of the rule is.
Okay. Okay, so I think I understood, but we have to go section by section. I know today you have to leave. So let's catch up on Tuesday. I'll set up a meeting.
Tuesday, Monday or Tuesday are best for me. So let's see what days you have available here. What times to have.
You let me know Tuesday actually, or Monday afternoon is fine. If you have Monday afternoon, which time zone are you in?
I'm CST.
Okay, I'm also CST. So let's do Monday at 1 p.m. It's fine. If or 2 p.m. If
1 p.m. I can do 1 p.m.
Okay.
I'll set up a call there for you.
Oh, okay. Okay, perfect. All right. And you have my email or no?
I'm sure I have, but why don't you give it to me there while
you're
standing?
Yeah. I'm going to send you an email. Okay, I just sent you without any body in it, so you should get it.
I'll stop sharing here now.
So now,
you said you sent me an email there.
Yes, I sent you an email so that you have my email address as well.
Okay, there you go.
You will see. I was not part of it until like last November. So few steps I don't know. I follow, but I'll need little bit of your guidance over here, like how it's done. But I think by and large, I understand what you are looking for.
Okay, perfect.
And I did talk to other people, and we are on board on this one to make it happen. So So since you are resource constrained, I went and I said like this will be useful when we are putting together our ADK, and then I think everybody was in sync.
That's great. Okay.
So I'll talk to you on Monday, and then I don't know. There is one question, like Boone has, you are from Intel, right, Boone?
No, I'm from Siemens.
Oh, no, Boone.
I'm a colleague of Tony Mastrooni, but I'm in the area of product strategy and technology on the
Oh, no, no,
EBS
no.
side.
I was asking about Boone, who is also in this meeting. He is from Intel.
Oh, okay. Sorry.
Boone. I think he's on mute. But I maybe like because they also have done like a lot of investment in 3D, so we can review with him in the next meeting as well. I mean, he might have few things to say.
Intel are one of the primary
Yeah,
contributors to the JEP30 part model. So
right.
very, very heavily involved in the development of that.
Correct. But yeah, okay. So let's catch up on Monday, and then we will yeah, and start working on this one.
Okay.
All
Perfect.
right. Thank you. Thank you.
All
You
right.
have a wonderful weekend.
Okay.
Yeah.
Great. And I unfortunately need to drop there now. So
Sure. Yeah, of course. That's why.
all right. Okay. Take care, guys.
Thank you.
Bye.
Bye.